Hi, so now we want to derive the equation of motion for 2 degrees of freedom by assuming compression. So we still have the similar picture, but now we want to assume compression. So you have K2, both sides of the arrow will go like this for K2 and C2. So basically, we have done with part 1, assume direction of the motion, because you already have x1 and x2 already given the direction. So you just follow that direction. The second step, we want to determine the relative displacement. So we know that in this case, we are looking into compression. Okay, so I have drawn the forces for compression, K2 and C2. And now we want to decide who gets negative, okay, based on the assumed direction. So if you look at this figure, basically this side of the arrow is the same direction to the right. So that means it will get positive. So x2 will get positive. Whereas this side, x1 will get positive. So this side, basically, maybe I change so basically this side is opposite than x2, so that means it will get negative. So if you want to write the equation basically, or the forces here for K2, so K2, the side that is x1 is positive and the side that is on the x2 side is negative. So you're going to get x2 minus x1. So same as for C2, if you want to write the forces, you get C2 x dot 1 minus x dot 2. Alright, so basically you already done with B and C. Basically, you write the forces according to the correct positive and negative direction based on the assumed direction. Then you also do the same for all the K1 and K3, C1 and C3. So do the same for K1. We are still 2C. You have to write all the correct forces. So for K1 and C1, it has to follow the direction of the motion to the right. So that's what you have here. And do the same for K3 and C3. So they also need to go to the right so that it has a positive force in the same direction as x2. So that's why you have to draw the arrow to the right. Then only we draw the action reaction, okay, which is here I put it in red. So now we just draw action reaction, which is opposite of all the forces. So that's not difficult. Alright. Okay. So then you have to write all the correct forces. I'm using this color. So for this one, you're gonna have your K1. So it's easy. Once you already follow the direction, it's all positive. So K1 x1, C1 x dot 1. And this one, all these four forces, the red, all the blue and the red, all has the same forces. So we don't have to write that. We just write for K3, then K3, X3. So notice that all will be positive. There's no negative forces here because we already follow the designations according to the direction. So we've done with the free body diagram. So similar process now for the EOM. You are going to focus only the forces on M1. So you only have 4 forces. So you can actually write and the positive direction you should follow x1. Yeah, because x1 goes to the right. So that's why positive is to the right. So the way to write it, you have m1 x double dot 1 equals to, so basically if you actually write based on this equation, so you can see that for m2, okay, so for m2 you only write the equations here. You can see that you have 4 actual reactions forces, and I just add F1 and F2 just to complete the problems. So you can see that both F1 and F2 are positive in this case, yeah. And the rest, if it's to the left, then it'll become negative. So this is the equations. Then you just need to rearrange, and you will check that this equation is exactly the same as the tension. So this is how it looks like if you rearrange these two equations. So you should get exactly the same as what in the note. So it doesn't matter whether you assume compression or tension. You can notice that the plus minus will change, okay, as well as the direction of your forces will also change. That's why at the end of the day you get exactly the same equation of motion. Okay, that's all.